Okay, so now we're going to do the polynomial of degree n. So that means we do not need to go and find the whole sum. So no sigma is necessary. So we don't have to end up writing the sum like that. We just get to write out terms. So Taylor, remember, is for the x equal a, and Maclaurin is when the x equal a equals 0, when you're using 0. So let's go do this one. So we still have to make the list of derivatives and plug in the a. So let's go find the derivative. So I get negative sine of x, second derivative, negative cosine of x, and then third derivative would be negative sine of x. See if I do that right. Cosine is negative sine, and then the negative carries, and that's going to be positive. I thought I made a mistake. Okay, so now we're going to go plug in 0. So f of 0 is 1. F prime of 0 is 0. F double prime of 0 is negative 1. And the third derivative at 0 is 0. So what we have to do is we have to fill in this formula. So, whoops, what did I do? I've got go up to 3. So let's change this. I put t sub 3. So that should be t sub 3. Polynomial of degree 3, so that means we go up to and include the third derivative. So t sub 3 of x will be f of 0, so that's 1, plus, oh, look at that, the first derivative at 0 is 0, so I get a 0 term, plus negative x squared over 2 factorial, plus a 0 term. Okay, so there is no third derivative term, so these two terms alone are the third degree Taylor polynomial, Maclaurin polynomial. So you don't have to worry about having this certain number of terms. You just go up to that number of derivatives and you get what you get. All right, here we go. So let's go write out our function. And you know the derivative of 2 to the x is 2 to the x times ln of 2. Second derivative, I'd get another factor of ln of 2, so that'd be squared. Third derivative, I'd get another factor of ln of 2. Oops, so that'd be cubed. So we see the pattern. So let's go plug in 1. So f1 is 2. F prime of 1 would be 2 times ln of 2. F double prime of 1 would be 2 times ln of 2 squared, and the third derivative at 1 would be 2 times ln of 2 cubed. Okay, so let's go plug that in. Again, I made a mistake. This should be 3, right? T sub 3. So I'm plugging in the Taylor polynomial. So I put f of 1 is 2 plus 2 ln of 2 over 1 factorial times x minus 1 plus, and I was going to come down here, 2 ln of 2 squared, x minus 1 squared over 2 factorial, and then last term, 2 ln of 2 cubed, x minus 1 cubed over 3 factorial. Again, that is the answer. You do not have to write the pattern of what the sum is equal to. All right, so here's another one. This should feel fairly comfortable. So f of x is e to the 3x. So one derivative by chain rule and two derivatives by chain rule, e to the 3x. So I think you get it, right? So this is Maclaurin polynomial, so I'm plugging in 0. So e to the 0 is 1. F prime of 0 gives me 3. F double prime of 0 gives me 3 squared. So I get the pattern. So going up to degree 4, I'd have 1 plus 3 x over 1 factorial, just put it in there for effect, plus 3 squared x squared over 2 factorial, plus 3 cubed x cubed over 3 factorial, plus 3 to the 4th, x to the 4th over 4 factorial. All right, I'm just going to finish them off. So let's go do this one. So f of x, you know, can be written as 1 minus x to the negative 1. So let's be careful in taking this derivative. So I get negative 1 minus x to the negative 2, doing chain rule, derivative of the inside. So fix it up right now. Then second derivative will be negative 2, 1 minus x to the negative 3 times a negative 1. So that gives me 1 minus x to the negative 3. And then third derivative, and that's just as far as I need to go. Negative 3 times negative 2. And then 1 minus x to the, negative 3 times 2. 1 minus x to the negative 4 times negative 1, so that gives me a 3 times a 2, 1 minus x to the negative 4. All right, so now I'm plugging in negative 2. Ooh, this is a little bit challenging. So I'd put in the negative 2. I have 1 plus 2, so that's 3 to the negative 1, or 1/3. So f prime of negative 2, it's going to give me 1 over 3 squared. And then f double prime of negative 2 will give me 2 over 3 cubed. And then triple prime of negative 2 will give me 2 over 3 times 2, over 3 to the 4th power. So now I go and put it all together. So my Taylor polynomial will be 1/3 plus 1 over 3 squared, x plus 2 to the 1 power over 1 factorial, plus 2 over 3 cubed, x plus 2 squared over 2 factorial, plus 3 times 2, 3 to the 4th, x plus 2 cubed over 3 factorial. Okay, one last one. So I've got my cosine here, and I know I'm going to be doing chain rule. So if I take a derivative, I get negative sine of x times 1/2. And how many derivatives do I need? I need up to 3, right? So I carry the negative 1/2, take the derivative, and get another 1/2. So that gives me negative 1 over 2 squared cosine of x over 2. Then I take the derivative again, and so last one, right, negative 1 over 2 squared, and this would give me a negative sine of x over 2 times a 1/2. So that would all give me 1 over 2 cubed sine of x over 2. Okay, so now I'm going to go plug in pi. So cosine of pi over 2, well, that's 0. F prime of pi, so negative sine of pi over 2 is 1, so I get a negative 1/2. Double prime, that gives me a 0. And third prime, that would give me a 1 over 2 cubed. So my third degree Taylor polynomial, it gets 0 minus a 1/2 x minus pi plus a 0 plus a 1 over 2 cubed x minus pi cubed over 3 factorial. And again, we don't need those 0 terms, so we're all done.